Hi, Professor.
Hey, good afternoon, Eva.
Good
Uh,
afternoon, Professor. Good
hey,
afternoon.
good afternoon,
Hey,
Peter.
Peter. Good
Hey,
afternoon.
what's going on, y'all? What's
Well,
going on?
I have only two, but very trustworthy two people, right?
Thank you.
Um, let's see.
Professor,
Yeah.
when are you gonna grade the exam?
Well, the exams are automatically graded. I mean, it's already been graded.
They don't show you the scores though. I think that's what she's
Oh, no,
asking
no,
for.
no. It's because there's a 24-hour hold period to prevent any possible collusion, right?
Oh,
So
okay, okay.
24 hours have already lapsed, so you can, I think it is visible now. Um, that hold period, I used to put like, even 48 to 72 hours because there are some people who, let's say, two students, A and B, and A finishes the exam first, and then he or she can access the result, and then he or she will be able to see correct answers, incorrect answers, correct answers, and then tip off. I mean, if they collude before the exam, and tip off student B, right? I mean, that's all possible. So and the exam, also think about it, the exam can be taken late. Uh, And of course, there is late penalty, 5% late penalty for each day late. But then the people, let's say, student B takes it after student A is done, and that kind of cheating is possible. I mean, even at the cost of 5% late penalty. I mean, let's say student B submits one day late, but after getting tipped off by student A. I mean, more than the student B can gain more than make up for that 5%, more than make up for that 5%
Yeah, that's
penalty.
true. I see what you're saying, Professor. Yeah,
Yeah,
that was
so
smart. That was smart.
that mhm. That's why there is a 24-hour hold period.
The grades are up
And
though. I see it.
mhm,
I
mhm.
said I see it. The grades are up.
Yeah, you can see it, right?
Yes, I see my score.
Hmm. Now, the so I have four people now here in the and four people in, so the numbers match. Okay, so we are good. I mean, four good people at least. Um, uh, yeah, and one more thing, I it's not. It's basically a competition. You have to understand. We're not. The exam is not where you practice the beautiful Olympic spirit. There was in the early Olympic Games in marathon. There was a runner who was in the lead group, and somehow his competitor, I mean another runner, somehow got, let's say, completely exhausted, so fell behind. And then this runner who was in the first place, kind of pitied him, or uh, I don't know, during that short period, during that short time of the competition, they may have developed camaraderie. But whatever it may be, because of the camaraderie or whatever, this guy slowed down and kept pace with this other runner who was falling behind, keeping him company all the way through. So he lost his first place, but that was celebrated as a beautiful Olympic spirit. But that's not what this is about. It's a competition basically. So you may help out each other studying together, but you shouldn't be helping out each other while taking the exam. That goes without saying. And the point is, you might think, if you might think that everyone can win out of this. No, it's either, you cannot all win. You cannot all be winners altogether. I mean, there has to be ranking, there has to be placement, because it's a competition, and there's no way around it. No way, so if you think you help out someone and that someone gets, 85, so then everyone gets, you get, A minus, that person gets, B plus. No, it's not going to work like that, because the way it is graded in this class is, based on the statistics. So, because if you you might think, oh, according to the BMCC grade guideline, below 60 it is fail, 60 to 65 D something, 65 to 70, C minus, blah blah blah. Above 93, that's A, 85 to 93, A minus. No, it cannot work like that. Why? Now think about it. There is no way you can make the exam so that the results will exactly norm, like the result will exactly be distributed like the guideline on the BMCC website, because you can norm it at 60 to as the cutoff line for pass or fail. Why? It all depends on the difficulty level. If the exam is very difficult, if the exam is made very difficult, then the average of the results will be somewhere around 40, right? Then, if average is 40, most everybody will be below 60. Does that mean most everyone failed? No. It just simply means if the average is 40, that means the exam was very difficult, right? You cannot norm F at 60, right? You cannot make it norm at that level. And if the exam was made very easy, then average will come to something like 80. If average comes to something like 80, then everyone gets, the majority of people get like B or B plus. No way, it can't work like that. If average is very high, that means the exam was very easy. Now you cannot, so in other words, it depends on the level of difficulty. So if the exam, and I have to factor that in, right? So, basically the way I grade is, if average, if you're around average, the mean will get something like a median grade. There are 9 grades. Right? 9 letter grades. From A to D minus, there are like 9 grades. So, and the median grade is B minus. Okay, the median grade is B minus. So the people in the, if you got something around the average, right, mean, that would be, that should be, that should fall into the median grade, B minus. And then also by standard deviation, depending on, how far you are away from the mean, then your grade will be determined. If you're, in the upper tail, if you are in the upper tail, far away from the mean, but in the upper tail, then obviously you should get, say, your 1.5 standard, 1.25 standard deviation above the mean, then you deserve A. You would fall into A. But if you're like 1.5 standard deviation below mean, you would be, in D, right? So even if, for example, mean comes out to 40, right? And that's the mean. And then if the standard deviation is 20, right? If you're one standard deviation above mean, 60, right? That would be 60. Then 60 is a good measure of cutoff line, cutoff point for A minus at least, right? So it works this way, not by absolute criteria. And then, so if you think about it, if you are in the upper group, and it's in the best interest of the upper group to keep the distance away as far away as possible from the middle group, right? The farther the distance, the more the distance between the upper group and the middle group. Upper group is in a very secure position, safe position to secure their gold medals, right? And if this gap between the middle group and upper group gets closer, then obviously it's not a good thing for the people in the upper group, right? You would have to either run faster or find a way to put more distance between the middle group and the upper group, right? So it's just like that. If you help out, let's say you're in upper group and you help out someone in the middle group or lower group, it will only raise the average. If the average gets higher, then you won't be you can't secure A, right? So by helping out people in the lower group, the average is raised to something like 80, and you're just 85. Obviously, you're not in a good, you're not in good shape then. You're in jeopardy. You're jeopardizing your own good grade because you helped out people in the lower group. The point is, it's not about beautiful Olympic spirit, right? It's about playing fair. That's part of the Olympic spirit. And it's a competition. And in a competition, you have to play fair. In other words, there should be no collusion, no cheating, and just let your ability speak for itself, and that's it, right? So so where were we? Okay, so in our last class, I was talking about the basically, finding that's to finding G, right? And or that's the same thing as R, right? I hate this. And the formula, I told you, it is something you already know. It's the formula for geometric average. 1/n minus 1. But how did they arrive at this formula? I mean, what's important is how and why. So what's important is how did they arrive at that formula, and Why? Why is it like this? So, and I told you last time that you must, you need to, I want you to study this slide, right? I want you to, so let's think about it. So we all know basically if okay, I think it's done. If y is x squared, right? We know how to, we know square root of x squared will be x, right? So if you take the square root of x, then you think taking square root is, simply doing this, but actually you would have to put 2 here because there isn't only square root, there is third root, fourth root, fifth root, any nth root. In other words, 8 is 2 cubed, right? So if you take the third root of 8, then it's 2, right? So that means, but this is an equation. Equation means, what you do to one side, you must do also the same thing to the other side as well. So that means you will need to do also, you'll need to take the square root of the left-hand side. And another way of writing square root is, I don't know why I used the same color there, but another way of writing a square root is, raising it to the reciprocal, half power. So the square root x squared raised to half power. What I have noticed is okay, that's square root. In other words, the way you write it, this is the properties of exponents. First of all, square root, you can write it like this, raising to half power. A third root raising to the third power, right? 1/3, right? 1/3, raising it to 1/3. So raising it to nth radical or nth root is, you'll need to raise it to 1 over n, right? And of course, the other side of the equation must be done the same thing. And you all understand some of the properties of, power or exponent is that we all know anything raised to 0 is 1. Anything raised to 0 is 1. And I'm going to give you an example later because, you just memorized it. You just memorized it cold without, really thinking about why and how. And the negative exponent is the reciprocal. In other words, a raised to negative b is actually 1 over a to the b. Okay? And the product of powers, like, of course, the base has to be the same thing. A to the B times A to the C is A raised to B plus C. Okay, so that's, something like that. We'll take a look at an example. So, for example, let me move this to the side so I can. So think about it. First of all, x to the negative 1 x to the negative 1 is 1 over x. That means, also then x to the negative 2 is 1 over x squared. Okay? And then another example. X then we all know x, anything raised to 0 is 1. And why is that? So think about it. Suppose we have then, x x squared times x to the negative 2. And what is that? X squared times x to the negative 2. Well, by the product rule, this is x to x squared plus negative 2, right? And then they cancel out. It becomes x to 0. And then think about it. Remember this rule, right? A to the B times A to the C, right, is A raised to B plus C. So that's exactly what I did. But then, so it's 0. But what does this mean? Think about it. We can rewrite the whole thing as, so x squared, the whole thing is, right, x squared times 1 over x squared. Isn't it right? X squared times x to the negative 2 is x squared times 1 over x squared. Then what should happen? They should cancel out. If they cancel out, this just becomes 1.
1.
What do you mean none? It becomes 1. Right? They cancel out. Think about it. Just plug in a number. Plug in some numbers. Suppose, this is 2 squared. 2 squared times 1 over 2 squared. Right? 4 times, that's 4 times, 1 over 4. It will have to become 1. Isn't it right?
Yeah, that's 2 squared have to cancel out.
What? Say that again?
I said you would have to cancel out the 2 squared.
Yeah, of course. In other words, it's just 4 times 1 over 4. That has to, it's just like they cancel out, of course, and then it's like dividing 4 by 4. That's 1, right? So that's why, instead of, just memorizing it cold turkey, anything raised to 0, right, is 1, right? But, instead of memorizing it cold turkey, if you just think, right? If you just think analytically, right, you'll get to the conclusion. And then Also, what else was? And there are other rules, but one thing that is coming in handy is power of power, right? And this is something we already know. Not this one. So in this case, right, why does that become, think about it. If I rewrite it, this can be rewritten as y raised to half power, which is, x squared raised to half power. But then the rule is let me write it. Let me write it here. The rule is, x to the a raised to the b is x to the a times b. Okay, that's the rule. So then this will be x raised to x squared, right, times 1 over 2. They cancel out. So it becomes what? X, which is, out of the square root, right, which is x to the 1, which is out, exactly out of the square root. So that means to take this out of the square root, you will have to do the same thing, right? To lose this exponent, right? To lose this exponent, you have to take the square root of that, or whatever nth root that may be. That's taking out of that radical sign, and you have to do the same thing to the left-hand side. Now, just to check some of those rules that for example, the product of power, right? X to the, so this one, in other words, let's confirm, right, and verify. X to the a times x to the b, which is it's going to be x raised to a plus b. Then just do the simple thing. 2 squared times 2 cubed. What is that? I mean, doing it like this is going to be 2 to the 5th, which is 32. But then this is 4. This is 8. 4 times 8, 32. Right? It checks out. And also, power of power rule. Think about it. As an example, power of power rule. Too much. Suppose we have 2 squared raised to the 3rd power. And then by the rule, we can simply do 2 times 3, which is 2 to the 6th power, which is 64. Right? It's 64. And then you can also do it. Oh, that's 4 to the third power. Try it. 4 times 4 times 4. 16 times 4. Therefore, 64. The same thing. Okay? So it checks out. So then back to this rule. This is what is going to save our day. Why? Think about it. We're going to use this. So suppose, so we have basically, starting from come on. Starting from this. Right? And our unknown is this, right? And then, so there is no way we can isolate R directly from here, but at least we can, whatever we can, we should isolate. First of all, we know the thing is, the whole structure is like Z equals X times Y format, right? It's like Z equals X times Y format. So, and the Y is the this whole chunk. This is Y, right? Make it a nice circle. And then and the Y is like, the R is in the cage. R is in the cage, and cage has a lock, a padlock, right? N is the padlock. So before opening up the cage, then what do we do? This guy is the guard, so we'll have to we'll have to lure the guard. We'll have to release the guard from the guard duty. So to do that, we will have to send the guard to the other side, right? In other words, it's Z equals X times Y. So just to isolate Y alone, what do you need to do? You will have to divide both sides by X, right? Then, you will have Y separately on the in other words, just to have Y isolated, you'll have to divide both sides by X, and you'll have Y on the right-hand side. So basically, I will divide both sides by P, and on the right-hand side, I will have only 1 plus R raised to N left. Then our next question is, this is now this whole this thing is like Z, right? And this thing and this thing is like X raised to Y, right? So like Z equals X raised to Y. So then think about it. How do you, just like this, how would you, you will need to get rid of Y, what do you need to do? You will need to raise the right-hand side to 1 over Y. In other words, you'll need to take the yth root, yth radical of the right-hand side, and you must do the same thing to the right-hand side, the other side, the left-hand side. And then think about it. Exactly that's what should happen. So then you will need to do then. Come on. FV over P raised to 1. And then 1 plus R raised to N. The whole thing must be raised to then 1 over N. Okay, and now, so this thing will be, I will just write it like, this, because I don't want to repeat the same thing over and over. The thing in the bracket raised to 1 over n, nth radical, and the right-hand side will be 1 plus r raised to n over raised to n times 1 over n. They cancel out. So now this thing is, the padlock is broken now. The padlock is gone. The padlock is gone. And then the right-hand side is free. Okay, the right-hand side is free. And then, so, and then of course, the cage is open, so it's 1 plus r. Okay, now I want to isolate only r, then what do I need to do? I will need to subtract 1 from both sides, and in other words, transpose, move the 1 to the other side. So then it's going to be FV over P raised to 1 over n minus 1 is r, right? Just rearrange that, put the r, then, just rearrange and put r in the left-hand side, and in the right-hand side, then it's going to be FV over 1 over n minus 1, which is exactly what? Which is exactly, sorry. Which is exactly this. Isn't that right? So that's how we got to this formula. That's how we got to this formula. Okay? We don't, although you only need to, you can, it would be easy if you just memorize this formula, but after the semester is over, most of you will forget. Most of you will, this will be long forgotten. You won't remember, these formulas, but, at least if you understand the steps of derivation, you can derive it. Of course, it takes a lot of repetition, it takes a lot of practice, because without practice, you can't do that. Anyway, but, the time it takes to the practice, if you keep memorizing the formula, it will stick to you anyway. But then the point is, everything is derived from the initial formula. Everything is derived from the initial formula, which is this, right? So starting from this, right? You can derive everything, and also even if you do not use steps of derivation, of course you won't use the steps of derivation. This is to show, unless you're a professor showing the students how you arrived at this formula logically, right? Instead of just enforcing them to memorize. the steps of their even if you you won't need to derive this all the time, and so the point is, although you just need to memorize only this, still knowing why and how we arrived at this formula will make a big difference. It gives you more confidence, and you can use this formula without with fully knowing that how it was derived, right? How we arrived at this formula. So, okay, without further ado, then let's go to someone left a message. When and how we are going to know our score of the exam. I explained this at the beginning, right? So will somebody, respond to Diop in the chat box? So let's go to our actual example, right? So we did this last time, so I want you to open that file again. We did this exercise last time, so I want you to open that file again. Okay. And go to row 18. So everyone has this file in front of you. Everyone? Everyone has this file in front of you?
Yes.
Okay, good.
Yes.
All righty, good. Only 2 people? Only 2 people. What about the rest of the class? I see 9 people. Ashley, you have this file in front of you, Ashley?
I'm looking for it right now.
Okay. You downloaded it last time, so it's in your somewhere in your either download folder or some folder. Edgar, do you have this file in front of you, Edgar? Edgar?
Not yet. I'm downloading it right now.
Okay. You don't need to. I mean, if you downloaded it last time, and if that file is still there in your folder, download folder, right? You just need to reopen it. Jamming, do you have this in front of you, Jamming?
Yes.
Okay, good. Jorge, do you have this in front of you, Jorge? Jorge?
Yes.
Okay, good. Mamadou, do you have this in front of you, Mamadou?
What's that?
Do you have this file in front of you? Not this one. You have
That
this
one?
file in front of you?
Yeah.
Okay. And Mohammed, do you have this file in front of you? Mohammed? Mohammed? Stacy, do you have this file in front of you? Stacy? Stacy? I would have to assume that Stacy is away. Zaid, do you have this file in front of you, Zaid?
Yeah.
Zaid, okay, good, all righty. So then if you have this file in front of you, go to row 18, delete all the highlighted cells, right? Now, so this question is quite obvious. You have $10,000 for principal, so you put 10,000. You have $10,000. You put it in the bank, and you have a 5-year timeline. This is your, okay. In 5 years, you want to grow this 10,000 to 30,000. You want to grow it to 30,000. Then the question is quite obvious. The only variable that is unknown is the APR, the interest rate, right? Annual rate. So then, okay, all you need to do is then just, build that formula in that cell. So it's FV over P is 1 over N, and N is in C18. And since the formula is, hanging over or overlapping that, C18, you can't click it in. I want to click it in, but you can't click it in. So then what do? You'll just have to type it in, and then -1. And be careful with the, always PEMDAS, right? because when you write it, it is obvious. We know it's 1 over n is the exponent. We know 1 over n is the exponent. But think about it. Excel, if you don't put it in the parenthesis, Excel will just raise this thing to 1 and divide the whole thing by C18, right? Because Excel wouldn't know if this is a one chunk, right? If this is, a one chunk, right? If you don't put it in the parenthesis, right? So always PEMDAS, and then -1, right? And there you go. You got 24.57. Yeah, that's pretty much, what it would take to what you're trying to do is triple your money, isn't it right? You're trying to triple your money in 5 years, and it would have to take a very high interest rate, almost 25% interest rate, right? Otherwise, you can't, reach this target future value, right? Okay, so that seems easy enough. But let's think about the row 20, right? Here, previously, that was, compounding frequency was just annual, right? Previously, compound. Now it's quarterly. If it is quarterly compounding, first of all, this formula is to find the periodic rate, the actual rate that applies. And so, but then what we need to find is, first the periodic rate, and then we multiply it by 4, then we'll arrive at APR. So that's more complicated. So it would be easier. I've been telling you, it's always better to make the formula simpler, right? It's always better to use the simpler formula than complex formula, because if something goes wrong, in a complex formula, it's more difficult to identify the source of the problem, source of the error. And it's even if you identify the source of the error, then it's difficult to fix the problem, right? But if you, so what I did was I, added 2 more columns, and I lightened the burden. I lightened the burden of the formula, right? Because I make adjustment outside the formula. So here, all you need to do, so over 5 years, since the compounding is quarterly, how many compoundings actually happen? 20. We know that because it's 5 years times 4, right? For quarters, right? That's 20 quarters or 20 compoundings. And with that, we can simply do, now the formula is a lot simpler. Future value, right, over present value, right? And these two over n. N is literally actual number of compounding. Now, I can't click it in, so I will simply type in F25. That's 1. There you go. So 5.65%, which is what? It's quarterly rate, isn't it right? It's quarterly rate. So then how do you convert it to annual rate? It's simple. Because this is quarterly rate, just multiply it by 4, and then that's the annual rate. Okay? So that's what you got. So APR is, because eventually what the problem was asking for was APR, so you will have to give it you will have to answer what is asked for. You don't have, this is not the answer. This is the answer because the problem didn't ask for periodic rate. Problem asked for APR, right? Now, then the question is, it takes lower APR. I mean, when compounding is annual, APR was almost 25%. Now it's only about 23%. So it takes smaller APR to get to the same future value, right? And that means, to put it in another way, we know that the higher the compounding frequency, the greater the future value, Meaning, if given the same P, same R, same N, right? Given the same P, same APR, same time, same number of years, the greater the higher the compounding frequency, it should arrive at a greater future value. But here, it's the R that was not given, and P and future value, principal and future value are already given. Time is already given. So, in other words, to arrive at the same future value, the only way you can do that, to arrive at the same future value, the only way you can do that is with a smaller APR. In other words, your money doesn't have to work that hard, right? It doesn't take that high interest rate to get to the same target future value, right? For the same time frame during the same time period, right? If the compounding is higher, if the compounding frequency is higher, right? So you might wonder, so if I do it this way, like this, then how should I do it? Well, it will be a little more complicated. Just a little, you need to make adjustments here and there. So first of all, FV over P, that's the same. Then divided by, raised to 1 over N. What is N? It's not 5, it's 20. So do you enter 20 manually? No, that's not a smart thing. That's a very dumb thing, because then you cannot reuse the model, you cannot reuse the formula over and over. So basically, what I do, it's basically C20, right? And since I cannot click it in, I will have to type it in. C20 times D20. Here, once again, think about PEMDAS. If you leave it like this, what's going to happen is 1 divided by C20 will happen first, right? But you don't want that. And then, D20 will be multiplied to that. But you don't want that to happen. You don't want it. You want this to happen first, right? C20 times D20 happen first. So you put it in the parentheses. Only then it will be 1 divided by 20 quarters, right? And then finally minus 1. And is that over? No. Why? Because see what happens here. If you hit enter, what it's going to give you will be just a periodic rate. And then you didn't answer the question. You didn't answer the question, is APR. So then what do? You'll have to then make another adjustment. You'll have to put all of this in the parentheses, and because that gives you that 5.65% result, you multiply it by D20, right? Because D20 is 4, right? Quarterly. You multiply it by 4, and it's going to give you exactly 22.59. Okay? So that's, once again, this will be a lot easier because by making adjustments outside, right, then you can easily identify the variables that go in there, and you can check if there's any error in it easily, and then all you need to do is simply again adjust the result, which is a periodic rate, by compounding frequency. So this way it's the maintenance, basically maintenance, right? Think about it. I told you before, I don't like Apple computers because Apple products, you can't fix it yourself. You can't. You can't upgrade it. You can't even, upgrade software, hardware, maybe software, maybe. You just need to download, the latest version. But then you cannot install any software yourself. You cannot install or take out any hardware yourself. Mac is a complete a black box. It's a complete black box, and I don't like it. It doesn't give me. And if you have a car and a car that takes a lot of maintenance, and the maintenance is very complex and very difficult, I don't like that kind of car. And most likely everybody else wouldn't like that kind of car. People like a car that is easy to maintain. All you need to do is some oil change every 3,000 miles, right? Just rotate tires every, every, 10,000 miles or whatever. If it has to be if it takes a expert mechanic, and the system is so complex, then even the expert mechanic would, labor over it. That's not the car that you can work on, right? So that's the same idea. If the maintenance is costly and it's complex, then that's not a good model. So in that, compared to this is a better model, right? And so think about it. You have to make a lot of adjustment here and there. Of course, this is not even this is just a very baby example of complex model. The model is, very complex, then it's going to be very difficult to. So some people might say, so why don't we use just Excel's built-in function? And I'm going to, no, again, it's a black box. For example, I already did it here, but I did it. It's after making adjustment. Suppose you're doing it by Excel, right? So it's rate, right? Basically, you're looking for rate. So hit rate, and it's asking for end period. So what are you going to do? You're going to put end period. So 5. That looks like, and if you do that, you're wrong because, and then present value, oh, this is the present value. And you will have to make it negative. You will have to enter it as negative because that's cash outflow. And then future value is cash inflow. You enter that. And so I entered everything. Voila, what do you get? You get also, use, 2 decimal, at least 2 to 3 decimal places, 2 to 3. What you got is only this, right? What you got is this. Why? Why did it happen? Because you just punched in without thinking. You just punched in the data without thinking, right? And I told you last time, I don't want you to become just data entry personnel. You should be the designer of the system. And then if you just punch in the data, what was wrong? First of all, n is 20, not 5. So you should have made this adjustment, right? So then by making that adjustment, okay, At least you are thinking, if you're doing this. Okay, then you end up with this. Why? Because then that's the periodic rate. It's going to give you periodic rate because it's 20 periods. Then some people just, without thinking, leave it like that. That's because they are not thinking, right? They are not a thinker, but just, data entry. Simple-minded people. They are not designed of the system. They cannot scheme anything. They can just do what they are told to do, but they cannot devise a system. To devise a system, you must understand the mechanism, right? So if you understand, what's wrong? Oh, because this periodic rate, then you will need to make complete adjustment, So it has to be, the result must be multiplied by 4, and then it's going to give you the correct, right? It's going to give you the correct result. Okay. So again, but then doing all this designing, right? Systems designing. If you can do that, if you can think to that level, then why not do it like this? Right? Why not do it like this? Okay, or like this, which can still give you, the handle on the mechanism. I suddenly have a headache, even to think of. Some people are, that's a bad case example. Of course, bad case example would be always about the thick-headed people that cannot visualize the system, the mechanism. And then even to imagine in my mind, that gives me a headache. That gives me my heart pounding because that makes my blood boil. Actually, my head is really aching just to think about it. So again, that's why I don't want you to use Excel's built-in function, because Excel's built-in function will just turn you into a data entry personnel, data puncher, right? Without thinking, right? It's also the GPS is a great invention of the modern times. Nowadays, a lot of people, simply plug in. They plug in their phone, and the Waze or Google Maps will show on the display screen, and then you just enter your destination, and you just follow the prompt from the GPS. But then that's turning you into a robot, isn't that right? That's just turning you into an automaton without thinking, because sometimes the prompt is a little there's a delay in the prompt, and it says make a right turn, but then you have already passed the intersection, right? You have gone through the intersection, and at that point you cannot make a right turn. But if you are just responding to that prompt, GPS prompt, you'll run into an accident, right? There's no right turn, but the GPS says turn right. You're gonna end up in an accident. So even if GPS is a good thing, before you go on a road trip, you gotta study the map. You gotta preview what route to take, and where will be the major turns, and where will be where will be the construction, or all these things. You better have that mental map. And then even if sometimes the GPS is giving you um, a, s- a stupid, direction. And there's and you know the shortcut. It's better to, and then the GPS will tell you to, uh, although you know what is the most efficient way, the GPS will tell otherwise. But then you need to override the GPS. You need to ignore the GPS and follow your own mental map, right? That's what is that kind of um, ultimately you're the decision maker, and that kind of understanding about the system or the mechanism is needed. But if you just use Excel's built-in function, then you're nothing but a data puncher, right? Or nothing but an automaton. All righty. Any questions so far? Any questions? Any questions so far?
No, no.
Okay. All righty. So then our next question is, we know very well now that there can be a question for every variable. I mean, every variable can be the unknown, right? In other words, we have covered all three variables for now, right? So first of all, when the future value is the unknown, we know when the present value principal is the unknown. In other words, how to find present value. When R is the unknown, right? We found it. And what if the N is the unknown? If the N is the unknown, then of course that's possible, right? You still have, your target future value is 30K. Your principal is 10K. And then interest rate. Interest rate is 10%. Everything is given. The only thing that is unknown is, so how many, so when you put 10K into the bank, currently and your target future value is 30K. Currently the market interest rate is 10%. Then what's going to be the, how many years will it take, right? How many years will it take? That's a conceivable question. And if that is the case, how do we proceed? How do we proceed? So we'll have to talk about this in the next class because we are, almost out of time. But one thing we need to start from, again, the whole thing is, we need to start from the basic equation, right? The basic primary equation is the compounding formula, right? And then now the problem is this is known, this is known, this is known, this is the unknown, right? So to isolate the exponent, how do we first we will have to, of course, isolate whatever we can. Now on the right hand side we will have 1 plus r. Then our problem is we are at a again dead end. I mean, it's not really a dead end, but we are, how do we proceed from here? Again, now the whole thing has turned into z equals x raised to the y, z equals x to the yth power, right? And then how do you solve for the exponent, right? We need to use, logarithm, log, but, it will take time, so we're going to talk about that in the next class, okay? Any questions so far? Any questions? Any questions? No? All righty, so then I will stop sharing. You guys have a great afternoon, and I will see you guys on
God bless you,
Thursday.
Professor.
All right, you too.
Okay,
You too.
Professor. Thank you.
All right, take care, Eva.
Bye,
Take care,
Professor.
Jorge, right? Yeah, take care,
Bye,
Jorge.
Professor.
All right, take care, Edgar. I will stop sharing, stop recording, and sign out.